In this video, we're going to talk about 3 new ways to wait using the Executor API and the wait function. These both apply to thread pull executor and process pull executor. We're going to show the examples with thread pull executor, but either one works. It's the same API. I'm going to import thread pull executor and the function wait, and we're going to see how that works in a minute. And then I'm going to name concurrent futures as CF because we're going to use some constants from that class. So I've got 2 tasks here. IO task, which is just going to sleep randomly between 1 millisecond and a second. And then I've got an IO task with error, which randomly throws an error 10% of the time. And we're going to see how that comes into play here in a minute. In the first one, we're going to create our thread pull executor with 20 workers. We're going to go through our typical range of 40. This is the example we've been using. Here, we're going to call wait instead of map, which we did in the first video. Then we had as completed. Now we've got wait. Now wait has 3 different options. So you use this return with, and you can call 3 different variables in with cf.firstCompleted, all completed, or first exception. So we're going to start with first completed, and this returns as soon as the first task is finished. And it returns done and not done. So it returns 2 lists. Done will only have 1, as we see here, because it returns when the first one's done. Now it'll keep working in the background on the rest of them. Where you could use this is if you made multiple calls to different databases getting the same information, or trying to scrape different sites, but you only care when you get 1 piece back. When its first one's completed, you could call cancel on all the futures and get rid of the ones that haven't finished. You know, there's some use cases where you only care for the first one that came back and all the rest of them are fine. It doesn't matter. Now in this case, when we ran it, it returned in basically 19 seconds, but it only had 1 done, which was the first one. So let's look at the second way to do this, and now we're passing in all completed as the return win. That is going to wait until every one of them's done. So you may have a variety of tasks here, and you can only move forward when all of them get done, but you want to start and do them all at the same time, but you need it all finished. So you might think of like cooking a meal in a restaurant. You can make the salad, cook the soup, warm the coffee. You know, there's all these things that can happen, but you can't take it out and serve the customer until they're all finished. That would be this all completed task here. The final wait option that comes is first exception. So here I want to keep doing work, but the minute there is an exception thrown, I want this to return so I can maybe do something about that exception. So it took 0.31 seconds and 6 of them got done before it hit an exception. So that's it. There are 3 ways to use the wait function, which give you 3 new ways to determine when you want to move forward. So you can do it when everything's completed, you can do it when the first one's completed, and you can do it when the first one throws an error. So that's it. Subscribe if you like videos about this topic, because I'm going to be coming out with more over time to explore the full concurrency options in Python. Smash that like button so I can help more people, and I'll see you in the next video.